Welcome to the second lecture on linear algebra. In the first video, we discussed about vectors, vector addition, scalar product, and linear combination of vectors. So from this video onwards, we will be looking at dot products and cross product and some properties of dot products and cross product. So dot product can be called as inner product as well, and the value of if you multiply two vectors, then the result will be a scalar, right? So this the answer of the dot product of two vectors will be a scalar. Now consider an arbitrary vector. For example, if I have a vector a and b, right? A and b, and let's say the angle between the two vectors is theta, then a dot b can be expressed as mod of a into mod of b into cos theta. Okay, so this is what we have studied in our advanced level. Now we are going to just extend this equation and write a new equation for the dot product of two vectors. So u dot b, right? So u dot b is nothing but u dot b. If I condense this equation, it will be easy for you. U a I b I is equal to 1 to n. So if I have vector u whose components are a1, a2 all the way to an, and vector v whose components are b1, b2 all the way to bn, then if I take dot product of these two vectors, then just simply I have to multiply the corresponding entries and sum them. Okay, so a1 b1 plus a2 b2 plus a3 b3 all the way to an bn. Okay, now there is a note. The vectors u and v are said to be orthogonal or perpendicular if u dot v is equal to 0. So this point you should bear in your mind, because when we attempt question, if we have a hint that the dot product of the vectors are 0, then we will say they are perpendicular. So for example, if I have vector a and vector b like this, vector a and vector b, so a dot b, and let's say they are perpendicular. A dot b is equal to mod of a mod of b cos 90. So cos 90 is equal to 0. So since this is 0, the entire expression will become 0. So a dot b is equal to 0 when theta is equal to 90 degree. So the vice versa, or the reverse part, is also true. When a dot b is equal to 0, we can say that the angle between the two vectors is equal to 90 degree. Then we can say the vectors are perpendicular. Now we will look at this example. We have to find u dot v, u dot w, and v dot w, where u is 1, minus 2, 3, and v, okay, the vectors are given. Now what we have to do is u dot v is equal to u 1, negative 2, 3, then v should be written second, and you have to put a dot here to represent we are taking dot product. So 4, 5, negative 1. So this will be equal to, I have to add the multiplication of the corresponding entries. So 1 into 4 plus minus 2 into 5, minus 2 into 5 plus 3 into negative 1. So the answer would be 4 minus 10 minus 3 will be equal to minus 9. Okay, I'm sorry. So minus 1 minus 9. Okay, right. Now u dot w. So in order to find u dot w, let me create some space here, erasing these stuffs. So u dot w is equal to, first we have to write u1 negative 2 3, and then we have to write w 2 7 4. So the answer would be 1 into 2 2 minus 14 plus 12, so 0. So we can say u is perpendicular to w since the dot product is 0. Then we will move to C part. C part, v dot w. So v dot w is equal to, first we have to write v, then v is 4 5 negative 1 4 5 negative 1 dot w should be written next 2 7 4, and then I have to sum the multiplication of the corresponding entries. So it will become 4 into 2 8 plus 5 into 7 35 minus 4, so it will be equal to 39. Yeah, 39. Okay, right. So now we will move to the next example. Find k. So this example, we have completed this example, and now we will go to the next example. So this example says find k so that u and v are orthogonal. So we have already looked at a note where we studied that if two vectors are orthogonal, then the dot product will be equal to 0. So u is given and v is also given. So if I take u dot v and equate it to 0, then I can find the unknown value in the unknown component of vector u. So 5k negative 1 dot product v is 3 to negative 1 is equal to 0. So 5 into 3 15, then k into 2 plus 2k, then minus 1 into minus 1 plus 1 is equal to 0. So I have just obtained an equation with one unknown variable. So this is very simple. 2k plus 16 is equal to 0. So k is equal to minus 8. Right. Now we have theorem 1.2. So for any vectors u, v and w in real space of some n dimensions, right? So this is nothing but real space of n dimensions. For example, if it is R square, then this is a 2D space, and if it is R cube, then it is a 3D space. Okay, that's just a group from which we are going to get the vectors from. And scalar k in R, now u plus vw is equal to uw plus vw. This is like a distributive law. Then this is kind of associative law. And u dot v is equal to v dot u, because it will give you the same value. For example, if you just consider the previous example, this one. Okay, for example, if you take v dot u, now v dot u is equal to, first v is 4 5 negative 1, u is 1 minus 2 3, and if you simplify it again, you will get minus 9. So the scalar product, I mean the dot product, is commutative. Okay, so theorem 1.2, the third part says this is commutative. And if u dot u, okay, dot product can be 0 greater, u dot u is greater than or 0, and u dot u is equal to 0 if and only if 0. So we will verify this. Okay, let's say if u is equal to a1x plus b1y plus c1z. Now if I take u dot u, I have to multiply a1, b1, c1, then a1, a2, I'm sorry, a1, b1, c1. Now the entries should be multiplied by itself and summed up. So a1 square plus b1 square plus c1 square. It is always positive, and the summation of positive will always greater than or equal to 0. That's why we say u dot u is always greater than or equal to 0. So when a1 is equal to b1 is equal to c1 is equal to 0, only u dot u will be equal to 0. Right? So if all the components are 0, then we will call it as 0 vector. That's what we have studied in the very first class. In the very first class also we had a note. Here you can see if the entries or elements of u, okay, for example, the vector 0, 0, 0, whose entries are all 0 is called 0 vector. So if the components are 0, then we will say the dot product will be equal to 0. Fine. Now we will go to the next point, which is norm or length of a vector. So the norm of a vector is nothing but the length of a vector. So if I denote a vector using a piece of line like this, and this length is called the norm of the vector, right? So we will denote is using two vertical lines, right? So if this is vector u, and mod of u will be equal to the square root of the summation of the square of the components, right? So it will be equal to, let's say u1 is equal to u is equal to a1, a2 all the way to an. Then simply we have to square all the components and add them, a1 plus a2 squared plus all the way to an squared, and we have to take the square root. Okay, so we will say the norm of u is equal to u dot u, square root of u dot u, and we have already studied that this is nothing but the scalar product. So this will be equal to a1 squared plus a2 squared all the way to an squared. Right. Now always the norm of the vector will be greater than or equal to 0. Again, if the vector is 0 vector, then the size also will be equal to 0. That is obvious, right? And that is what they have given here, if and only if, right? So this will be equal to 0 if and only if u is 0, right? So the norm of the vector u will be equal to 0 if and only if u is equal to 0. Now we will see unit vectors. For example, if I want to find the size of vector u here, now simply I have to u mod of u will be equal to u dot u square root, right? Let me erase all these things. Oh, I need it. Okay. No, because if I keep them, it seems to be messy. Okay, right. So this will be equal to 1 squared plus negative 2 holding squared plus 3 squared, and we have to take the square root. So square root of 1 plus 4 plus 9 will be equal to square root of 14. Okay, right. Again, similarly, we can find the norm of v and norm of w as well. So please do it yourself and give me the answer in the comment section. Now we will look at unit vectors. So unit vector is a vector whose magnitude is 1, right? So for example, if you have a vector whose magnitude is 1, right? So you can just obtain the magnitude of u, that is called norm of the u. If this is 1, then it is called unit vector. So how we are going to obtain the unit vector is just dividing the components of the matrix by its norm, right? So first we have to find out the norm of u, and let's say we have u is equal to a1, a2 all the way to an. Now each element of vector u should be divided by its norm. So u head, this is called unit vector is equal to a1 divided by mod of u, comma a2 divided by mod of u, norm of u, up to an divided by norm of u. Okay, so this will give me the unit vector. So for any non-zero vector v, right, because the vector should be a non-zero vector, and the v, this is nothing but if this is vector v, and unit vector v will be equal to the vector should be divided by its norm, which will return this expression. Okay, right. So now the process of finding a unit vector from the vector is called normalizing the vector v. So in the tutorial discussion we will be doing a lot of example questions where we will normalize vectors. In that process we have to just divide the vector components by its norm. Okay. Now we will do this example. Let u is equal to this and v is equal to this. Then find mod of u, mod of w, and normalize u and w. First, from u we have to find out norm of u. Norm of u is equal to square root of u dot u, which will give me the answer 1 squared plus 3 squared plus 4 squared plus 2 squared and square root, and this will be the answer. So square root of 1 plus 9 plus 16 plus 4. So I will use my calculator to find out the value of this. Square root of 10 plus 16, 26, 30, right? Square root of 30. This will be equal to square root of 30. And norm of w will be equal to 1 by 2 holding squared plus 1 by 6 holding squared plus 5 by 6 holding squared plus 1 by 6 holding squared square root. Now this will give me an answer. Now let's say this is m, right? So I'm just finding the value, and the value is m. Now to normalize vector u and w, now what we will do is unit vector u will be equal to 1 should be divided by square root of 30, comma, then minus 3 divided by square root of 30, comma, 4 divided by square root of 30, comma, 2 divided by square root of 30. This will be the answer. And for finding the unit vector of v, I just want to divide the components of w by its magnitude. So w, unit vector of w will be equal to 1 by divided by m. So whatever the value that we find for m should be written in the denominator, right? Comma, minus 1 by 6 divided by m, and so on. Right. So this is how we are going to normalize vector u and w. Now we will do a theorem 1.3, which is called squash inequality or Cauchy-Squash inequality and Minkowski triangular inequality. Now I will make separate videos explaining the proof and verification of these two theorems, and we will move to the next topic called distance. And in the tutorial also we will be having some questions where we have to verify this relationship, this inequality and this inequality. This is very simple. Taking examples for u and v, we can verify this theorem and we can prove it as well. Now distance. vector u and v, and now we have to find the distance between u and v, right? So if u is equal to a1 a2 all the way to an, and v is equal to b1 b2 all the way to bn, now distance of u comma v can be written as the norm of u minus v, right? So the norm of u minus v is nothing but u minus v into u minus v. This is dot product, and we have to take the square root. So first we have to find u minus v. So u minus v will be equal to a1 minus b1 comma a2 minus b2 up to an minus bn. So u minus v will be equal to a minus b1, a1 minus b1 holding square plus a2 minus b2 holding square up to an minus bn holding square, and we have to take the square root of this, right? So this is what is mentioned here in the lecture note also. And let's say the angle between the vectors is equal to cos theta, which means we have u and v like this. Let's say this is u and this is v, right? So as I wrote here, u can be written this way. Then any vector u can be expressed uniquely. Uniquely means this is how we are going to write this, right? So u is equal to a comma b comma c, which means ai plus bj plus ck, right? So this is the coefficient of I, and b is the coefficient of j, and c is the coefficient of k. Since the vectors I, j, k are unit vectors and are mutually orthogonal, now you see I, j, k. So this is I, let's say, and this is j, and this is k. So I, j, k are mutually orthogonal to each other, which means I dot j is equal to 0 because perpendicular, but I dot I is equal to 1 because they are parallel, right? Which means I dot I means mod of I, mod of j, I'm sorry. Here you see if I have I dot I is equal to the norm of I again into cos theta. I dot I means I is here lying on the x-axis, again the next I is also lying on the x-axis. So the angle between these two factors is equal to 0, cos 0. So now mod of I is equal to 1, since that is a unit vector, into 1, and cos 0 is equal to again 1. So I dot I is equal to 1. Okay, but I dot j is equal to 0 and j dot j. So the same thing you can do for j also. So j dot j is equal to mod of j, I mean the norm of j, into norm of j into cos 0, because the angle between j and j is 0 because they are lying on the same axis. So here this will be again equal to 1 into 1 into 1 is equal to 1, and k dot k. Okay, right? And we will be like this: 4 minus 8 and 7. Now if I add u and v, I have to just add the corresponding entries. So u plus v will be equal to 3 plus 4. So I have to just add the I component and j component and k components together. So 3 plus 4, 7, then 5. So 3 plus 4 and I. 3 plus 4, 7i. Then 5 minus 8 minus 3j. Then this and this. So 7 minus 2 plus 5k. And now 3u minus 2v. 3u minus 2v means now I can write this like this: 3u minus 2v is equal to, now the vector u should be scaled by 3. So 3 into 3, 5, negative 2, and minus 2 into 4, negative 8, 7. So if I distribute the vector u by 3, then 9, 15, minus 6, minus 8, minus 16, plus 14. Now 9 minus 8, 1, right? So 1 into I, and 15 minus into minus plus, then it will become, if I am not wrong, 31, but positive 31j plus, now plus this minus 6 minus into this minus, so minus 6 minus 6 minus 6 minus 14 minus 20, k will be the answer. Now u dot v is equal to, summation I is equal to 1 to 3, since we have 3 elements in the vector ai, vi. So this will be equal to 3 into 4 plus 5 into negative 8 plus minus 2 into 7. So this will be equal to 12 minus 40 minus 14, and 12 minus 40 minus 14. Minus 42. So u dot v is equal to minus 42, and now we can find the norm of u. Norm of u is equal to u dot u square root. So the components of u vector should be multiplied by itself and then summed up, and then we have to take the square root of the resultant value. So here 3 squared plus 5 squared plus 2 squared will be equal to 9 plus 25 plus 4. Square root of 38 will be the answer here. Square root of 38. Okay, now we will move to cross product. Okay, fine. So cross product. So earlier we discussed about dot product which yielded a scalar. Now we are going to find another vector that is the product of two vectors. Now let's say this is A and this is B, and we have to find a vector perpendicular to the plane in which the vector A and B are lying, and that vector can be obtained by the cross multiplication of these two vectors. So u cross v, right? And this is how we will express the cross multiplication or cross product of these two vectors. Now this will be a 3 by 3 matrix having the I, j, k as the first row and the components of u and v in the second and fourth row respectively. Now we will just do this example, and we know how to obtain the determinant of this 3 by 3 matrix, and in the next chapter we will be going through deeply about the determining the determinant of matrices and inverse and all the things related to matrices. So here if I hide this column and this row, so I into, and we have to multiply this way, so a2b3 minus a3b2 minus, then j. Again if I hide this column and this row, then a1 a3 a1 a3 minus a3 b1 a3 b1 plus k. Now again if I hide this row and this column and this row, a1 b2 a1 b2 minus a2 b1, and don't forget to put line under the letters to represent the or mention their outputs. Now we will so 9I minus, now if I skip this column and this row, 4 into 1, 4 minus 12, 4 minus 12 minus 8, then plus 8j. If I skip this and this, minus 12 minus 6 minus 18, K will be the answer. Okay, now another question is given. This is very simple. U cross B is equal to, the first row should be I, J, K, I, J, K, but they have given in another format. The vectors are given in using a triplet format. So 2 minus 1, 5, 3, 2, 1, and then you can find the answer. Now, if we have I cross J, now we know that the product of I, J should be a vector